Hey, what's going on, guys? Let's do this problem right here. This question is asking whether this expression converges or diverges. To find this one out, first we have to take the limits. And if you look at this one, the limits of integration going from 0 to 33, and when it's 1, if you apply 1 for x value, this is going to be 0 right here, right? So when it's 0, we will get undefined. So here we have a vertical asymptote, that is x is equal to 1. So in this case, we have to break this down into two parts. So when we break this down, this is going to be 0 to 1, 1 over x minus 1 power 1 over 5 dx plus 1 to 33, 1 over x minus 1 power 1 over 5 dx. Now before we go and do this problem, let's go ahead and find the integral of this one first. If we integrate this one, so when I do the integration, I shouldn't take this limit. So let's do without the limits and take the integration. So this one also can be written as x minus 1 power negative 1 over 5, right? Negative 1 over 5 dx. Now if I do the integration, we have to add 1 more to the power. And if you add 1 more to the power, that's going to be 1 is same as 5 over 5. So if you add 5 over 5, you will get 4 over 5, right? Then we have to divide by the same power. So dividing by 4 over 5 is same as multiplying by the reciprocal. So if we multiply by the reciprocal, that's going to be, so instead of dividing, let's multiply by the reciprocal. So this reciprocal of this one is going to be 5 over 4, right? So that's going to be the integration of this one plus constant. Now let's go ahead and do this one. Here we have these two integrals. Now if one of them is divergent, we don't have to do the other one, because if one of them diverges, the whole thing will diverge. Now let's see whether this converges or diverges. Let's take this part alone and see whether it is converges or diverges. To find that one out, we have to take the limit. So here, whatever the vertical asymptote, we take that as t. So t approaches 1 from the left side, so this is going to be 1 minus. And then instead of 1, we replace that one with t. So this is going to be 0 to t right here. And then we are going to have 1 over x minus 1 power 1 over 5 dx. Now instead of integrating this one, we already integrated this. That is this one right here. So we can replace this one here. So this is going to be limit t approaches 1. If I integrate this one, this is going to be x minus 1. It's actually x minus 1. X minus 1 power 4 over 5. And then we have 5 over 4. So let's write 5 over 4 right here, and this is going from 0 to t. Now let's apply this t first. So this is going to be limit t approaches 1, and we are going to have t minus 1 power 4 over 5, and 4 we have 5 right here, and also minus x minus 1. So this is going to be 0 minus 1, 0 minus 1, also we have 5 right here, 4 right here, 5 over 4, 0 minus 1, power 4 over 5. Now let's simplify and see what we get right here. If you substitute 1 for this one, 1 minus 1, this will make this one 0, and if this is 0, everything is going to be 0. So we can put 0 right here, and here we are going to have minus. And this is negative 1. 0 minus 1, that's going to be negative 1. Negative 1 power 4 is going to be positive 1. Positive 1, fifth root of positive 1 is going to be positive 1. So we are just going to have 5 over 4 right here. So the answer here is going to be negative 5 over 4. So this part converges because we have a finite number. So this part converges. So we have to do the other part too, to find whether that one also converges. Now let's go ahead and find this one. This is going to be again same approach. Instead of 1, we replace t. So this is going to be limit t approaches 1 from the right side, and this is going to be 1 over integral, so we have to put integral first, integral t to 33, 1 over x minus 1 power 1 over 5 dx. Now we have the integration already, so we can plug that one right here. This is going to be limit t approaches 1 from the right side, and this is going to be, integration is going to be 5 over 4 x minus 1 power 4 over 5, and that's going from t to 33, right? T to 33. Now let's substitute the values. First we are going to have limit t approaches 1 from the right side, and if I substitute 33, this is going to be 5 33 minus 1 power 4 over 5 over 4 minus 5 t minus 1 4 over 5 over 4. Now let's do the simplification. In the first one we are going to have 5 times 32 power 4 over 5 over 4, and this one is going to be 1. So if you substitute 1 for this t, this is going to be 0. 1 minus 1, that's going to be 0. If this is 0, the whole thing is going to be 0. So this is 0 right here. So all we have to do is solve this part right here, and we know that fifth root of 32, that's going to be 2. If you multiply 2 5 times, that gives us 32. So this is 2. Then we have power 4 remaining, right? So 2 power 4 is going to be 16. 16 times 5 is 80. 80 divided by 4, that's going to be 20. So 20 minus 0, that's equivalent to 20. So this also converges. So from now on, we already know this is converges. And if you calculate the final value, that's going to be 20 minus 5 over 4. And this is going to be 80 over 4 minus 5 over 4. Finally, you will end up with 75 over 4. And that's going to be the answer. Since we have a finite number, we can say this expression converges. So this is a convergent expression, right? And that's going to be our final answer. I hope you guys find this video helpful. See you next time.